Hey folks, we're going to go ahead and get started. We've got two more sessions. The DevOps session, we're here today with John Willis and Katina Gunderson. And I'm pleased to introduce Katina Gunderson to you guys. She's got 18 years of experience in the IT consultancy and management profession, focused on enterprise organizations and helping them through transformations. For the past 2 years, she's been working here developing our DevOps practice, which is now a nationally available program. And in her off time, she's practicing for a ballet, or is it a ballroom dancing in June? So let's hear for Katina, our Director of DevOps. Thank you.
Well, hello. Woo. I managed to karaoke last night till like 2 in the morning, so my voice is a little bit rough. I apologize. Welcome. Did you guys all see Gene Kim earlier today? Awesome, huh? I'm glad he did the hard work of explaining what DevOps is to you, so I don't have to. So we had to start there, but we've got a good frame of reference, and we've got an awesome speaker for you for this session. I'm going to talk at you just a little bit. So from a DevOps perspective, Trace 3 believes that DevOps is all about modernization and transformation of the entire organization. It's not just about the tech, people, although we love tech here, I know we love it, but it really is about the people in the process. And if you don't have either of those things lined up, the tech goes nowhere. Build it and they will come, and this world does not happen. Gene talked a lot today about creating the high-performing organization, and we believe that that is truly what DevOps is going to enable. We also prophesize that in the future, DevOps is just going to be. It's no longer going to need a label. It's just going to be how organizations are functioning and how everybody's performing and delivering features, functions, and services internally or externally to customers. So the people and process part is something that we're very passionate about. From the standpoint of DevOps and what it is, I won't get into the definition, but we believe that it's a practice. It's not just a tool. It's not a person. It's not an admin. It's not only something devs do. It's not only something the IT ops do. It's not only something that QA does. It's something that the entire organization has to do and embrace as a practice. It's all about creating continuous collaboration, continuous feedback, allowing people to fail fast with forgiveness, without fault, and it is truly about creating that high-performing org at the end of the day. We go into customers and help them with their transformations, with our consulting practice. We're not just coming at it from the tech angle. We are bringing the people and process. Our practice is comprised of a bunch of brilliant architects and engineers, but we also have brilliant management consulting level folks who are coming in and focusing on the organizational change management, the culture transformation, the lean process improvement activities that need to happen, and trying to bring it all together and really wrap it up to help organizations transform. We're doing those transformations start to finish. We're doing them everywhere in between. We're getting surgical. We're solving problems. All organizations are snowflakes, but I was told by one of our practice members that all snowflakes are made from water. So there are definitely commonalities that we're seeing in the marketplace and seeing the problems that organizations are having in this. I think it's been pretty fascinating, quite frankly, as we're going out and helping customers. So really quick, I want to have the team stand up so that if you do have DevOps questions after this, you can identify the guys in the hoodies. As of right now, I'm the only woman, so find the boys. They can answer questions and share their war stories and probably commiserate and collaborate on whatever problem you're trying to solve if you are doing any kind of a DevOps movement. So next, I want to take a second and recognize Cisco and thank them very much for their Evolve sponsorship and making this breakout session specifically a possibility for us. I'm going to stand up. Thank you. I think one of the things I want to put a plug out there from a Cisco perspective is that I think Cisco, like many organizations, is also innovating fast, right? And recognizing that the DevOps movement is happening, and it's happening at a very rapid pace. I think we're super thrilled and excited about their recent additions of AppDynamics, Clicker, now Cisco Cloud Center. They've also got a pretty accelerated chat ops tool called Spark. And I'm imagining that there's a whole other host of DevOps tools that they've got their eyes on because the market is moving quickly, and all of the little guys want to be part of the big families. So again, thank you very much. And finally, to get to the main event, I would like to introduce a phenomenal individual, a digital influencer, a DevOps evangelist, a thought leader, a recognized DevOps authority across the nation. And he is here to talk with us about a whole host of things. I just want to outline some of his credentials, though, because it's pretty impressive. So, and I got to read my notes because there's a lot going on here. So, co-founded Socket Plane, served as DevOps evangelist for Dell, has held various executive positions across companies like Chef and Canonical. Hopefully I said that right. Today, he is currently the director of the ecosystem development for Docker, and he's going to be talking to us about something extremely sexy, DevOps, and security. And he's going to talk about the intersection and, of course, infuse a little bit of Docker in there. So let's give him a warm welcome.
Clicker. The clicker. So it appears I've been promoted. I am a digital transformer now. That could be cool. So I don't have my timer, so I want to make sure I don't go over too much. Also, nobody's ever used the word sexy with me, so thank you. She told you a lot about this. I mean, I'm easy to find. The hardest thing about finding me is that word botchagaloop. But if you get that, then you can find everything I've got, including all my presentations over the last 6 years or 7 years. The biggest thing is the DevOps handbook. I also do a DevOps Cafe podcast I've been doing for 7, 8 years, a labor of love. A lot of startups, 10 startups, a lot of failed startups. And the startup guards have actually been nice to me in the last 5 years. Sold a company to Dell, and then 2 years ago, I sold a company to Docker. And I just want to point this out. This is a labor of love. It took me a year to write this. I was originally asked to write a course for the Linux Foundation on edX based on the DevOps handbook. I added way too much more stuff in there. It's just like the kitchen sink of anything that could be related to DevOps. It's a free course. Oh, hey, somebody's trying to call me, so that's no good. All right, so let's have a little fun first. So last year, I was at an Alibaba China Cloud Conference. And somehow, I don't realize that I do this kind of stuff. But somebody got this picture. It's horrible, right? And these young gentlemen at a company called Heavy Water decided to just go nuts, So the thing is, here's the thing. You have PhDs, you can have all this stuff, but you ain't nothing until you've been memed. And now I've got to stand like this on stage because if they continually catch me in other moves. And yes, I was there. I'm old. Seriously now, folks. All right. All right, this is the part where you say, okay, he was funny, now he's full of crap, okay? What if I told you you could be 2,000 times fast? Actually, you heard some of this morning. Was everybody in Gene's presentation this morning? Okay. There's a lot of stuff. We actually have a lot of shared slides. So I'm going to be able to go fast through some of this stuff, right? So let's see. And then what if I told you you could be 100 times more reliable? And what if I told you you could have both? I'm going to walk you through a set of, I think, principles and practices. And I will use an actual case study of somebody who presented this at RSA earlier this year that basically achieved those two numbers. And the way you achieve those numbers, basically DevOps, and a lot of this overlaps, right? So there's pieces of Docker and DevOps that overlap. But I would say that in DevOps you go faster. You actually get more reliable, but we'll talk about that. And you saw some of that this morning. Dear Gene King, everybody. Gene, here, come up here. No, I'm kidding. Docker, I will show you that in combination with DevOps, you get more effective. And that's actually been the mainstream why Docker's been so popular. We'll cover that. But then there's a third piece, and this one hit me like a ton of bricks. Because I had been going around talking about DevOps and these patterns of how you can do containerization. I'll describe it a little later, called immutable delivery models. And I knew there was this thing that bugged me, which was, okay, John, and I would wait in the audience like, please don't ask me this question. What happens when I have 1 million of these things or 5 million of these things in the wild? How do you manage them? And I ran into a gentleman named Josh Corman, and he was giving his presentation on supply chain and security. I'm like, aha, that was the peanut butter and chocolate moment of that we could have both. And I'll go through this. So the DevOps, you've heard a fair amount of DevOps, and you heard a great explanation of a lot of the componentry of DevOps from Gene this morning. A lot of our slides match. To me, this is the best slide. It was actually produced by a guy named Andrew Schaefer years ago, but popularized by my friend Damon Edwards. It tells you kind of everything that you want to know in one picture about DevOps. So Gene talked about lead time, right? That's the thing, right? We want to shorten lead time. So we get this kind of first way mentality, left to right. We want to shorten lead time. We have, on the bottom, we have amplification of feedback loops, right? Which is really that second way Gene talked about, right? We want to kind of condense and amplify, move the feedback. He talked about the end-on chord. I'm going to talk a little about that later. And in the middle, we have that culture piece. And originally, it was dev and ops, right? That was the kind of the picture that we saw originally. In fact, the joke was a bunch of startup people, developers, started these startups, and they draw straws to who would get ops. And the short straw would be the ops person. And what would they do? They would actually start thinking like a developer. So kind of DevOps in a form was born, right? But it was about removing the wall. You know, in the classic IT enterprise, it's to throw it over the wall. Hey, what did you guys do? Hey, why did you break it, right? And so, so this kind of removing the wall. Now, here's the other thing, too. People get all spun up on DevOps, MarkOps. It's a metaphor. Now it is a metaphor. It's a metaphor for groups that can't collaborate and that we want to make sure that we collaborate. So you don't have to create these long out, 400-character names with everything that is in your organization. Mark, Dev, Op, Sec, Op, do. So early on in this movement, if you will, Damon and I, so the first DevOps days ran in Ghent. It was like 35 people. The second one, we had like 300 people in Mountain View 6 months later. And in one of the podcasts, we were just so blown away from what we had experienced. Me and Damon kind of came up with this accidental taxonomy. I'll call it a loose taxonomy. We call it CAMS, Culture, Automation, Measurement, and Sharing. And one of the things we emphasize quite often is that without the culture, without these behavior patterns, the automation, some people say CAMS, not AMS. Doing a bunch of automation and telemetry where you don't know where you're going, or you don't have kind of a behavior or collaborative culture. Gene talked about John Ospar's seminal 10 deploys a day at Flickr. The biggest part of that presentation was how they had to collaborate to make that happen. And you saw Gene's 3 ways, and what I realized recently is that kind of the AMs match the 3 ways, just like the previous picture. And so the DevOps Handbook is, I'm proud to be part of this. I mean, I'll say maybe I was the dumb one out of the 4, and so I could say it's an amazing book. I mean, even like when I was in final edit, I was reading and I'm like, is this my book? This is amazing. I mean, it really is a good book, 48 case studies. But in fact, there was at DevOps Days Austin last week, somebody got up and said, you know what? Stop with the definition of DevOps. Stop it. And they held up the book and said, just read this book. Right? I mean, it blessed my heart, right? So it's about continuous delivery, right? Like that's kind of a lingua franca here. DevOps doesn't equal continuous delivery. Continuous delivery doesn't equal DevOps, but it is probably the strongest pattern that we see. And then, the culture, right? Like everybody's responsible. I despise the word project. I try to knock people down in the knees when they even say product. It's about service. And so there's no done. Done is released, but really there is no done. A service is something that has a lifeblood. If you talk to some of the companies that think this way, the only way to get out of that service is get a job transfer, get fired, or deprecate the service, right? Because what's done? And then there's the stop the line, which is the kind of the metaphorical end on chord. And so you saw this morning, right? Right? Like this was the 2015 data. People are like, why do you put up the 2015 data? Because it was the aha moment. Like early on in the movement, I would always say, I know this is the right stuff. I know if you do it this way, you'll faster and be more reliable. And there was a bunch of us saying this. But Gene and Gabe and Nicole came in, and Nicole's a PhD, statistician, psychometric, all that stuff, and showed through rigorous statistical analysis that you can go faster and have higher quality. So that was the year where it was yes, now we have data that shows indeed there are. And by the way, folks, there's a cultural pattern. Gene talked about the Ron Westrom organizational culture. So this survey basically asks you a bunch of questions where you self-identify whether you're a pathological organization or you're a generative organization. Mixed into those questions, they're asking you how often you deploy and how often does it take you to fix things. And the data correlates together that the generative cultures are the ones that are 200 times faster and actually 255 times faster in 2016. And 168 times better at storing stuff. So guess what? That golden triangle that we've lived by for years, pick 2, or more importantly, the dev versus ops. Dev wants to go fast. Ops says, no. It's gone. In fact, the data now shows that you can actually be more resilient if you go faster. And so what does this break down to? It breaks down to building automation that builds that resilience, that anti-fragility into the way you deliver stuff. And this is a 2006 slide from an Agile conference, 2006, right? It shows this, how you build automation that becomes that, that telemetry and amplified feedback loop. Developer submits a code, bank, hits a build unit test, goes back, red. Developer fixes, goes back, bang, hits red, goes back. So you're constantly evolving this resiliency in your kind of pipeline. And when you get really, really good at it, if you want, I won't have time to tell you a story. Me and Gina talked about recently where people have converted a mainframe application, IBM mainframe to Java, and did it without, like nobody questioned it. It went seamlessly because they'd take 4 years to build a structure like this. So Gene talked about the end-on cord, right? So there was actually a rope in Toyota that anybody could pull at any time, for any reason, to stop the manufacturing line. And I love this part. It's in a book by Mike Rother called Toyota Kata. Anybody would guess what the first thing that the floor manager would say to the person who pulled and stopped the line? Stop the line. There'll be some cheaters at the dinner last night, so it was thank you. Before that person even knew why they pulled the cord, it was thank you. That's a psychological safety model. When we talk about culture, that kind of culture where you could stop the assembly line, and it wasn't like, what'd you do? Oh my God. It was like, thank you. You know why he said thank you? Because it was a learning opportunity. There's a story, Gene talked a little about this morning. It's the plant in Kentucky, Toyota plant in Kentucky, that produced like 2,200 cars a day. And an analyst went down to this plant and said, how do you create 2,200 cars a day? That's amazing. And the answer was, we pull the end-on cord 5,000 times a day. You heard that story from Gene this morning, right? This like counterintuitive nature, the more you break it, the faster and better you get. So guess what, folks? This was Gene's numbers too, right? These numbers are actually double. I saw Google SRE last week, and these are all double, basically. Now, this is like from 2013. But here's the one that, like, in the conversion from Keynote to PowerPoint, gets a little lanky here. It's like 120 million test cases a day. You know what that is? That's that Kentucky plant in a software version of the 5,000 end-on pulls a day. Yeah, you could hate or love Google, but their services are like incredibly resilient. And if you want to read an amazing book, the Google SRE book that's recently come out, tells you how they operate. If you read that book and then ask your boss to do those things, you will get fired. But you should read the book. And then there's the, if you've watched any of the DevOps presentations over the years, everybody will throw in the Amazon story. And again, these numbers have gone up over time. But, basically, at one point, 1,000 max deploys to production an hour. Right? So, and it isn't the numbers, right? It's the, like, how good are you doing? How resilient are you, right? Back to this number, right? So, shamelessly stolen from a gentleman called Pete Cheslock. He actually used to have DevOps as the unicorn and security as the one that has to shovel the poop. But right about now, there are certainly a bunch of you, and I wouldn't ask you to raise your hands because you wouldn't do it. You're saying, this guy is so full of crap. He knows nothing about large enterprises. So how dare he come in and fling this unicorn poop all over us, right? Well, first off, I did start, my first job was at Exxon, but like we wouldn't even go there. As Gene talked about this morning, we've been running this DevOps Enterprise Summit. The book has over 48 case studies. Here's the thing. This is the thing that was, again, warms my heart, which was early on, there were a lot of people who would say to us, you were a bunch of kids. That going fast stuff is never going to work in large companies. And I told Gene, I couldn't wait till we ran the first DevOps Enterprise Summit to show these stories of they didn't compromise. It wasn't like, well, in the big companies, you can't really do that and that and that. And then companies like Ticketmaster, Nordstrom, and Target show up and say, yeah, no, we did it exactly like, the web scale companies are doing it. And, little tweaks, a lot harder, more business units. But, Ticketmaster, 98% reduction MTTR, Nordstrom, 20% shorter lead times. Target has 15,000 square feet in their headquarters up in Brooklyn, Minnesota, that is called the DevOps Dojo. Started as a room. Now it's a learning organization. And this isn't like one of those showcase innovation centers. Every time I go tell people, hey, you should do that, oh, we got one. And then you walk by and it's a glass window this thick, and people wave as they walk by the innovation center. No. This is where you come in and you actually participate. You learn how to do a Kanban. You learn how to do pivots. You get infrastructure built for you instantaneously. There's a waiting list at Target to get into this place. There's couches and display areas. Gene told you about the CSG. Look, so there's when we wrote the book, there were like 48 case studies. There's probably now 50, 70 more great case studies they're all on YouTube. In fact, my class catalogs a lot of those. All right, so then I said that there were three components. Certain was DevOps, second was Docker, and I said Docker was effective, right? And go back. I won't bore you here, but people say, well, Docker is just containers. Yeah, and the slides will be up. You can get it later, but this is kind of the history of like cloudy Docker container. But the Linux containers in 2008, really mostly driven by IBM and Google, was really the kind of the big thing. And then Docker was actually online PaaS that decided to pivot to just open source all the things they were doing internal, which was where they're building everything on container infrastructure. So short lesson, right? Type 1, type 2 virtualization. Docker relies on what's called an OS level virtualization. It's basically process-based. So you have an operating system that's process-based. There are, LXC is, and Docker is just an abstraction of LXC, Linux containers. And so what does this mean? Well, a couple of things. One, if the startup time, so what happens in a container is it relies on the kernel of the host. And it runs basically through a kind of a root, but a create process, if you will. And so what happens is this compute type instance instantiates mileage of arrays in 400 milliseconds, 500 milliseconds, as opposed to 2 or 3 minutes from a VM. The footprint is like sometimes 100 meg versus a couple of gig. So you start adding that up, the density of the speed. How fast can you launch 1,000 compute instances? How long does it take to deinstantiate those? So you get this like incredible density of memory, even network bandwidth, of course the images, also the speed of instantiation and deinstantiation. It all adds up. And by the way, we find very rarely is there a case where you can't containerize. I mean, if you're still running a DOS application, God bless you, we can't help you. That one comes up quite often, more often. But the XP ones, I know a company that took a fleet of 100 XP servers, they converted them into containers, running Alpine Linux, using open source .NET libraries. And the developers are like, what just happened? Oh, that's fine with me. Think about that. Think about last week, a couple of days what happened. Where we have a large insurance company that converted old .NET applications running on XP that they felt they were stuck with for the rest of their life. And they actually moved them over to Alpine Linux running containers. They provision in milliseconds, bare metal speed, VM-like agility. Very rarely can you not find a use case where, reasonably modern use case where you can't containerize something. By the way, they're now supported on Windows. Windows 2016 actually ships Docker. So those processes basically almost 100% compliant with the Linux-based one. This was a report. This was interesting. One of the things I've been kind of munging on, trying to get the brave enough to really do it, is to say that, hey, by the way, your containers are more secure than your VMs. And I can make that argument, but I'm not going to make it today. But this is something interesting about IBM where they say, I'll just skip to in general, Docker exceeds, it's a very rigorous report, exceeds KVM performance in every case test. Often results show that KVM and Docker introduce negligible overhead in CPU. Right, so if you get all that density and it works, and by the way, findings now that, when we started going into bare metal virtualization, right, what it was, most of the bare metal machines were 8 or 9% utilized. So oh my God, we're going to put 4 or 8 or 10 on there, and life is going to be so good. You know what we find consistently now? VMs are about 8 or 9, 10% utilized. So if you're spending $30 million a year on a VM farm license, and you can reduce that, just say conservatively 40%, and everything kind of runs the same, just saying. So isolation, lightweight, right? That's Linux containers. The place where Docker, what is Docker? Why do they love Docker so much? Oh my God, will you shut up about this Docker, right? It was the simplicity in the workflow. The guy who found it, just understood. He actually modeled it after Git. He knew that you were going to have images. And if anybody tried to do Linux containers before Docker, it was a pain in the ass. He just made everything so easy so that when you ran, if you haven't done Docker, literally, I'm kidding, I don't care what you do. Go to the simple getting started, and it'll blow your mind how easy it is to get started by running a container. And then we've really beefed up the security. The thing that kind of annoys me sometimes is you see people say, they'll sit up and they'll be presenting slides 3 years old. The thing about Docker is it's great, it's amazing, but don't run it in production. Well, first off, I can name 5 fintech, Wall Street fintech organizations that are running production applications with Docker. Okay, so throw that one out the water. But we had some security holes early on, just like Linux did when it first came out. But we've really put incredible amount of investment. People say, how did you get all that money? What did they do with it? Well, we spent a lot of it on security. We have built-in security scanning, so we do vulnerability scanning. And it's world-class scanning. You can have signed signature images. So the images will be signed. You can put policy on the images. Who can use them? We have this thing called trusted registry, so all your images, don't worry about where they come from. You can build them and migrate and manage yourself. Everything's encrypted. Even our VXLAN, my company was an SDN play for Docker. Right? You can create SDN or VXLAN overlays, encrypted overlays. Read-only containers, user namespaces, totally compliant with SEComp and LSMS. The other thing that's really cool, now you can go nuts here, but we broke out all the syscall capabilities. Oh, there we go. That could be a picture right there. No cameras. We broke out all the capabilities. Now, this is really cool. This is why I say you can really get down to bare. In fact, a lot of the DoD uses this. I mean, we've turned all those syscall into flags. Turn this off, on, off, on. Now, you better know what you're doing at the kernel level because things ain't going to work. But if you know what you're doing, you can lock it down. We added secrets management. In fact, I should update. This is the one, at the end, I'm going to make a compelling story. And they're going to have to drag me off the stage if I run out of time, because I am going to tell this compelling story. This is actually called Linux Kit. I should have updated it. We just announced it at DockerCon a couple of weeks. It's an immutable operating system. And I mean immutable. It's an open source. It was actually written by the guys who wrote all the unikernel stuff, if you've been following that thread. It's an immutable operating system that you define with YAML. So now you can have a service where not only all the service components of it can be defined in source control, the actual associated operating system can be defined at the service level. So now you can build an atomic delivery of a service where the operating system, all the componentry, the application are all built in source control in this YAML-like file for the service definition. And so you've just DevOps, excuse this one, but DevOps, the complete horizontal chain of delivery. And it's immutable. And by the way, the only thing that runs on this, so it is a completely read-only operating system. You cannot change anything. You have to rebuild the application from source control, from a delivery, a CI/CD commit. But here's the thing, everything that runs it is in a container. So it's double isolated. So that last presentation was amazing. But imagine if your operating system is immutable, and you have these immutable objects that are your containers that are running your applications, it gets really interesting. I'll kind of skip this. This was Guilt a few years ago at one of the Docker cons, and they just talked about immutable delivery and why they love Docker. And they talked about, the reason why they like this is the developers could create this was actually before we had some other features. They could create a simple YAML file, and they didn't have to worry about what language, what, the delivery, what release engineering scripts. They literally they had complete control. And it even says, I don't care if it's Java, Ruby, Python, even if you made up your own language. Developers didn't matter. And that's kind of the beauty when you kind of think about how you containerize things. I know I'm blowing through it pretty quick. Yeah, okay. I got some more here. And then so I'm going to finish up with, okay, I told you about speed from a DevOps perspective. I think Gene did a great job. If you're not convinced, then you should leave now. But hopefully I've given you a little insight to why containerization. The one thing I haven't really told you is that there's this idea of what I call immutable delivery. And so the developers now can create the services and test their services against other services on their laptop. and then push that through the pipeline. And if it goes green through the whole pipeline, when it gets to development, it's the same bit and byte image that they had on a laptop. So you decrease the variation, and you have this immutable model. So the idea, somebody mentioned like developers wearing pages, right? Developers love paging when they get woke up, and they're pretty certain that it's either their problem or an operations problem, because they know that what they had on their laptop was basically the same immutable object that is running on. But then in the beginning, I told you I worried about, like, okay, now if you have, they said that Google, this is 3 or 4 years ago, would run 2.2 billion containers, not Docker, but containers a week. It's probably 5 billion now. So how do you, like, what would you do? And it all goes back to somebody called Deming. I'm a big fan of his. And there's a great story about the supply chain, Toyota supply chain model. Just quite frankly, like if you look at these numbers, like the top numbers are pretty obvious. Like Toyota beat the pants off of Chevy. The retail price was 61% better. They sold more units. But here's where it gets really interesting. Basically, Toyota did, they had 800 suppliers, or plus the 5,500 firm-wide suppliers, and Toyota only had 125 plus 224. So Chevy had way more outsourcing, right? We've been told outsource, right? Take a look at the in-house production. The in-house production is that that Chevy, with way more outsourced providers, did twice as much in-house work. And Gene referenced this a little bit about Google. Said that Google has only one of each. They actually have two, sorry, Gene. But they have 2 Linux kernels. They have 2 Java logging frameworks. They have a strict adherence. In fact, the healthcare gov had 17 Java logging frameworks. And they were on like 2-year-old application. That's how crazy it gets. But here's the thing. Like Deming said this years ago. If you don't know Dr. Deming, look it up. He said that the more supply, you don't want a lot of suppliers. In fact, you would really like just one. And the reason is that the overhead, like managing suppliers is an operational cost. It causes more scuff. And so what the supply chain thing says is fewer and better suppliers. Guess what? That's what Google does. Why does Google get phenomenal numbers? Because they minimize the variability on their suppliers. They said this in the SRE book, they have this thing called the Death Squad. Now, I think it's an inappropriate name, but like they'll literally, in the book, they said they'll come into your office and they're like, hey, you're running an old version of the Linux kernel. And like, yeah, okay, great. Thank you. And they'll just stay there, tapping their feet. No, you can leave now. No, this is my job. I'll just stay here. Actually, Gene does this. I got to call you out. Like, when you got to do something with Gene, he won't let you get off the phone. He'll make you do it while you're on the phone. And it's a brilliant habit, because usually he knows me. It'll take 2 weeks later, and they'll remind me, and like, hey, why didn't you do that? So it's the same thing. This Death Squad was like, no, I can wait. So there's fewer supply. How many Java frameworks? How many Java logging frameworks do you have? How many versions of operating systems do you have? I know it's not easy to change, but that is what causes you incredible operational costs. Use higher quality parts. Well, that's that pipeline. The Toyota version of higher quality parts is building those pipelines, the continuously automated tests, behavior-driven tests, the red-green chart I showed you. And the part that was magic to me, which is a third principle of the supply chain, is put bill of material and manifest that you know where everything is. And with containers, it gets way better, because remember I said they're atomic and they're associated with a service? Now it gets really easy just simply to put the SHA commit, who did it. I know every container. I got 10 million containers. I know exactly who the last person who touched it, down to the atomic service that it's running. Better yet, I have bill of materials in there. I've got department codes. I can put as much meta as I want in there. So when I have zero-day attacks, I can find out everything that's running in the wild. The one security gentleman said, how often people don't not know what's running in their site? What if every service was in an image that had a complete manifest in it? And one shell script, or a node if you want to be cool, basically could tell you everything that's out there, because every service is defined by this atomic image. And so they talk about the 4VL from Toyota, and it's decreasing variety, it's increasing velocity, right? It's decreasing variability. I'm a big fan of Chef and Puppet. I was the 9th person in Chef, and I have stock in there. But I'm telling you what, infrastructure as code, as you build at each stage, adds a level of variation. Manufacturing, and guess what, folks? Software is manufacturing. Gene pointed that out a little bit this morning. Decreasing variability is the game. It's probably the most important game. And then visibility is that, can you put that metadata in these, this blasting of all these images that are running out there? So instead of going, oh my God, what's going to happen when we have 15 million containers running? No, that's going to be great. Because now, for the first time ever, I can tell you exactly where all our resources are. And so I wrote, when I got to Docker, you saw the 3 ways from Gene this morning. When I got to Docker 2 years ago, I wanted to write this paper about, how Docker had a 4VL all fit together, in the first way, second way, third way. So it's a white paper out on Docker that really goes through this, a little more detail, a little less. I've learned a little since I've written the paper. And so looking at the 4VL, right, we go back to the, how do you get to that aha to ka-ching, which is that original picture. We use fewer and better suppliers, higher quality parts. We track parts. Our variety are things like, basically learn faster, limited frameworks, velocity, small batch, small teams, microservices and containers play really well here. Variability, immutable delivery, as I've described, again, very quickly. And visibility could be all the security stuff I mentioned, but also this concept of inloading your bill of materials, inloading your kind of manifests, and just the simple idea that the person who did the commit, the last change, is atomically identifiable in the running instances that change was associated with. And so there's a gentleman early on wrote this really cool blog post, Ari Paneer. He was one of the original Puppet guys. When he first started working with Docker early on, he was like, how am I going to operationalize? And he put all this stuff in every container. And he shipped a simple script called container sh. And he could basically just do it, and it basically mapped and pulled out all the containers that had any of this information that he needed that was already built in at source control. So we've talked about this. You've heard a lot about security. I've given you a little glimpse where I think that you can be more secure with containers. Somebody I was talking to last night was kind of thinking I'm saying that with Docker there's no more security concerns. That's ridiculous. Right? Sometimes you say stuff in passion and people take it to like, oh, that guy's telling me. That's not what I mean here. I'm just saying there are levels of this immutability, the supply chain, and this kind of DevOps. And what really kicks it off is this idea of DevSecOps. Now, I've always been against morphing the name DevOps, but I think now I'm seeing these presentations that are blowing my mind. So early on in DevOps movement, the QA people were all freaking out. Oh my God, I'm going to lose my job. And we said, no, calm down. Like, we're going to put your tests in, and like you're going to be part of the automated chain. Like, thanks, okay. In fact, their jobs got more important. They got paid more. And then for the longest time, security, like the gentleman before, was like this little, glass fishbowl. Well, now it's the same thing. It's like, well, first off, security bugs are bugs. Hey, let me say that again. Security bugs are bugs. Like a bug is a bug is a bug. And so now the security people are like, hey, this is pretty hip. Gene was involved a little bit, this rugged, but now DevSecOps, I'm seeing at RSA, there was a couple presentations. This idea that you put all the security stuff overlaid on that pipeline. So your requirements, you static analysis. In your CI, you do automated analysis, container. Now again, containers, because they're atomic, you get this atomic level of vulnerability scanning. You have a detection. So you now have this kind of overlay of all the tools that are now mapped basically on top of this. Oh, what happened? Okay. So 2 more slides. So I heard about this story about 2 years ago, and they didn't disclose who it was. And in RSA, they disclosed who they were. A friend of mine, Josh Corman, was the one who told me this story, the guy who we did the peanut butter and chocolate thing. So about, 5 or 6 years ago, and they're in a application, decided to go DevOps. They started out, before they went DevOps, they would track Sev 1, Sev 2 security bugs per 10, and they would start with 10 per 10,000 lines of code. And then they basically said that after they did DevOps, they got it down to 4. They added, through Josh's influence, supply chain, got it down to 1. Added Docker immutable delivery pattern, got it down to 0.1. And here's the thing. That was 2 years ago. At RSA this year, the gentleman who was managing this told me that number is now 0. And that's a pen test, a bug fest 0. And then the gentleman who was there came up to me. He didn't know me because I didn't know these guys directly. He said, "You work for Docker. I love you." And I'm like, "Hey, wait, I didn't write it. Calm down." And then he said, "John, I got to tell you what I love about Docker." He said, like if this doesn't warm your heart, I mean, literally, if this doesn't warm your heart, then like you're in the wrong line of business. Sorry. One service, one container, one read-only file system, and this is the one that should get everybody, one port. There's some immutable, beautiful in this. Imagine one port. How many people have worked with like IP tables and firewalls? And imagine this: one service, one container, one read-only file system, one port. Warms my heart. Thank you, everybody.